this sections, we're going to talk about solving formula for a variable. So first example we have ay plus b equal to c, and we're trying to solve for b. When do we use this? Well, let's say that we don't always asking for one of the unknown variable. You have to maybe solve for the other one. And if you started with the formula for solving for that one variable, sometimes it's easier. So let's see. So how are we going to solve for this formula for a variable b? What we're going to do is what we did it with the simple equations. So we're going to isolate the b. So we know we wanted to isolate b and get rid of everything else on the left side. So on the left side, I have ay is attached to b by adding. So you're going to subtract both sides by ay. Then you end up getting b equal to c minus ay, right? So solving means that you wanted to isolate that one variable and move everything else to other side, like solving linear equations, the simple equation we just did from previous sections. What about this one? Solve for a. When you see fractions on a formulas, first thing you wanted to do, you don't even need to know where the variable is at. You just wanted to get rid of fractions first. So how do we get rid of fractions? By multiplying a over 1. So you multiply by a over 1 on both sides. When you multiply both sides by a over 1, this a cancel out. So you have no more denominator. All denominator is 1. But on the other side, you're going to end up getting AR equal PL. Now, soon as you don't see any fraction, let's locate what you're trying to solve variable. So you're trying to solve for a, and your a is right there, and you wanted to isolate that. And it means you need to divide both sides by r to get rid of the multiplications. Then a is equal to PL over r, right? What about next one? Next one, where are we solving? We don't have fractions, so we should be able to locate what I'm trying to solve. Is right there, right? So let's try to solve for L, and I see the parentheses. So let's get rid of that parenthesis by distributing first. And then you wanted to, again, isolate L right there. So let's start moving. When you're solving for equations, to get rid of everything but that one variable, you're doing the opposite of order of operations. So you get rid of addition, subtraction before multiplications. So this subtraction I will get rid of by adding Rx on both sides of equations. Then I end up getting M plus Rx equals RL. And then we divide both sides of equation by R again to isolate L. So then you have M plus Rx all over R. Let's look at another one. So this problem you wanted to solve for B, and your B is right here, right? And I see fractions. So I wanted to get rid of fraction by multiplying both sides by L. Then I get LQ equal K Ka B minus C. Let's open the parenthesis by distributing Ka B and Ka C. And then again, what are we solving? We're solving for B. And I see only one B, so let's get rid of everything else that's attached to B, and we need to get rid of addition subtraction first. So you're going to add to get rid of subtract. So you get KAB on one side. The other side will be LQ plus KAC. And then in order to isolate B, you need to divide by Ka. So that will give you 1. So you do the same thing on the other side, where your B is going to be equals to LQ plus KAC over KA. Let's do another one. This is going to be last one, and this is one of the longest one too, right? So first thing I see is parentheses. I don't have fractions, so I don't have to worry about fractions, but I see the parentheses, so let's open that. So then I get 3as1 plus 3a times a is going to be a squared. And once there is no fractions and no parentheses, then let's locate what we're trying to solve. S1, right? We're trying to solve for S1. I got one S1 right there, and I got another one. So it looks like I have more than one. So if you have more than one of the variable that you're trying to solve, then you wanted to put them all into one side. Remember solving simple linear equation before, right? If you have more than one of the variable x, you put it all one side to make it 1, right? That's what we're trying to do. So we wanted to put it all together. So it look like I will have a as 1 and positive 3 a as 1 become negative 3a as 1 when you move to other side. The other side you have 3a squared, and move the term without the s1 on the other side will be negative c s2, right? So again, I move this to right, this to right, and the other one to left, right? So then I should be able to, from this two, I cannot combine because you have different terms, but you can factor S1 out. So when you factor S1, you're going to have a minus 3a remains. Which is going to be negative 2a equal what else we had on the other side? We had 3a squared minus c s2. So now if I wanted to isolate s1 by itself, this is multiplications, so you're going to divide this by negative 2a. It means you're dividing the other side of equation by negative 2a also. They cancel out. You have S1. Let me erase that. S1 equal 3a squared minus cs2 over negative 2a.